Hello there. Today we want to explain the project specifications and the other things. It is the base case code for all the files and the result of the base case. Before we start in the code, we will explain the project specifications. The first thing is that it is the title demand response of the AV in IEEE 33 bus using a PSO. The test network, it is IEEE 33 bus, and the optimization methods or algorithm PSO particle swarm optimization, and the optimization variables that the program it is optimized. It is the power charging and discharging from the AV. This is the optimization variables that the particle swarm theorem optimize this variables to minimize the object function. The object function it is the minimize the losses in the IEEE 33 buses, minimize the peak load, that the maximum load during the days, and the last one it is the system and AV customer cost. It is two side, one-to-one system cost, minimize system cost and minimize the AV customer cost for charging AV. And in our optimization, during our optimization, we have constraint on the function, the line limit, the line between two buses, limit rating, and it does not reach some rating, and the location of AV it should be also take into consideration, and the state of charge for AV, ability to charge and discharge in the AVs. This is the constraint. It should be taken into account on our optimization. The input parameters that make assumptions or from some reference, the unity load profile for the IEEE 33 bus. This is how to the load, but in the per units. So it is per unit multiplied by the maximum load at IEEEs. So this is the load profile, how to the load in the each buses behave during hours and during the days. As you see here, this is the peak load there at 18 hour 18, 1.4, and this is the load profile, unity load profile. And after that, the charging and discharging price. As you see also, it is from the reference the time of use rate schedule for AVs. As you see here, this is the charging price during the days for 24 hours, and the same thing, it is the discharging price for the 24 hours. And after the third one, it is the charging levels. The charging level mean that what is the level of the charging in each homes or stations. It is AC, the reference it is AC level to 7 kilowatt charger per hour. And the energy charging location, this is assumption. As you see, AV aggregator, the number of AV, this is number of AV at bus. As you see at bus 6, we have the 75 AV aggregator, and the same thing at 18, 100 AV aggregator, and so on. This is for all the buses, and the total number of AV in our system it is 825. And another parameters, input parameter, it is the AV parameters. The state of charge threshold between 20% to 80% state of charge. The battery capacity it is 60 kilowatt hour. The energy consumption per kilowatt 180 watt per kilowatt. The charging efficiency, discharging efficiency, it is 90%, and the vehicle to grid power, that mean the vehicle can discharge to the grid by 7 kilowatt per hour. And the next one, it is the time to arrive and departure distance. As you mentioned before, we divided into the 10 profile, and this is take it from this reference. This is the schedule, the table. It is contain the departure time, the arrival time, and the assumed distance for all the type of profiles or type of customers. And after we finish from the inputs and assumptions, now we have two cases to compare between them. The first one, it is the base scenario, a case that without demand response for EVs, electric vehicles. The second one, it is the optimization scenarios with demand response of EVs. In this next video, we will explain the base scenarios, how to act, and after we finish the optimization scenario, we will also make some other videos to explain the optimization scenarios. But before make the optimization scenario, we will explain the base scenarios and wait from you a feedback about the base scenarios. If you have any comments and any other adding values or adding something on the base scenario and optimization scenarios. The last thing, it is the result and the graph. What is the result and the graph expected from our code? The power loss, the voltage profile of the system, total system cost and the customer charging cost, load profile, and peak load AV profile. This is all the result and the graph. In the next video, we hope it is clear for you the project specifications, and if you have any question, we are ready. We are ready to answer you and help you. And we hope it is understand everything. And if you have any question, just ask us, and we will answer you. Thank you very much, and we hope it is clear for you. Thank you.